All right, we are on the third page of this packet. And so we're going to talk about the power rule for exponents. But first, let's go ahead and look at this particular problem. So if we have 5 squared, and that's raised to the 4th power, that seems like there's a lot going on. But let's think about this. Okay, what is 5 squared? Well, 5 squared, right, is the same thing as 5 times 5, right? So 5 squared is the same thing as 5 times 5, and 5 times 5, all of that is raised to the 4th power, which means 5 times 5 is our base, and that is written, that would be 1 time, that would be 2 times, that would be 3 times, and this would be 4 times, right? And so if you look, all of these are multiplied by itself. So the answer would be 5 to the 1, 2, 3, 4, 5, 6, 7, 8. So 5 squared, the quantity 5 squared raised to the 4th power, is really the same thing as 5 to the 8th. Now, doing all this makes me so happy. I love to see all this wonderful work, but I swear your book insists on me teaching these cheat rules, and it just makes me so mad because I love you guys showing all of this work. So this is cheat rule number 2, which I like to call the power rule for exponents. Now what this says is that if you have a base and an exponent, right? And then that base and exponent is raised to another exponent. You see we had the base and the exponent, and then that's raised to a second exponent. What it says is this is the same thing as keeping the same base and just multiplying m and n by each other. So really, if we had this problem, the cheat rule says, and I hate doing this, but you know, the book makes me do it, so whatever. The base is 5. Okay, so then the cheat rule would just be 5 to the 2 times 4, which is 5 to the 8th power. Boom! I know, this is so much easier. I just love the hard way for you guys, but you know, let's keep it going. So let's look at a different, so that's cheat rule number 2. It's called the power rule for exponents. So let's look at this other example. It says, similarly, we can simplify an expression like the quantity 6a squared by to the 3rd power by applying the same expansion and collecting like terms. So if you see, there's a lot going on in these parentheses, and that is to the 3rd power, right? So we have 6a squared times 6a squared times 6a squared. 6a squared is times itself 3 times, which we have here. And then what do we have? We have numbers, and we have a, the variable a, so that has the base of a. So this is the same thing as 6 times 6 times 6, right? And then we have a squared times a squared times a squared. So 6 times 6 times 6 is 216. And then here, since these are all multiplied and have the same base, we can do the product rule, which is a to the 2 plus 2 plus 2. Right? And once you simplify that, you get 216a to the 6th power. So this makes yet another rule for exponents, or cheat rules, as I like to call them. This is called the power product rule, which it combines the product rule with the power rule. So power product rule for exponents, which just states if you have things that are in parentheses, a, b, right? And it's raised to the nth power, n goes to a and n goes to b. So this is the same thing as a to the nth power and b to the nth power. All right, let's look at a few examples here. So we have the first one, 2 to the 5th raised to the 3rd power, right? So we're just going to do that power rule, which is going to be 2 to the 5 times 3, which is 2 to the 15th. Boom, done. Okay, let's look at b. Okay. We have x to the 4th raised to the 2nd power. So again, that's going to be that power rule, which is going to be x to the 4 times 2, which is x to the 8th power. All right, all right. Then what do we have? The quantity 9xy all squared. So that means each of these things gets squared. 9 gets squared, x gets squared, and y gets squared. So 9 squared is the same thing as 9 times 9, which is 81, x squared, y squared. There we have it. Then we move on to D, which is negative, the quantity negative 4a squared. So we can look here, so that means that negative 4 gets squared and a gets squared. So negative 4 squared is the same thing as negative 4 times negative 4. A negative times a negative is a positive. 4 times 4 is 16. So we end up with 16a squared. And lastly, let's look at this problem. So here, notice the difference. The negative is inside the parentheses, and the negative over here is outside the parentheses. So let's see if that has an effect. So when the negative is outside the parentheses, this squared does not apply to that negative. It only applies to the things that are inside the parentheses, which would be the 4 and the a. So the first thing I'm going to do is just write that negative, and then everything inside the parentheses gets squared. So only the 4 gets squared, okay? So not the negative, and then a gets squared. And so we just leave that negative, and then 4 squared is the same thing as 4 times 4, which is 16, and then a squared. And there we have it. So there is a difference. So when that negative is not inside, it doesn't end up getting squared like it did over here. When the negative was inside the parentheses, it actually got squared, and negative times a negative is a positive, and so our answer was positive. Okay, so now it's time to turn to worksheet number 2. Let's go ahead and look. Okay, worksheet number 2 is on page 10 of 15. Do you see the page numbers right here on the top? So go ahead and flip to that page, please. Okay, are you there? Did you find it? All right, perfect. Okay, so I just want to pick about 3 problems to do. What are some good ones? 2 or 3. Maybe I'll just do 2 problems. Let's see. I'm kind of feeling like 7 is a good one. And maybe... is 7 a good one? Or 7 too easier? Let's see. Maybe 7 and 11. Okay, let's start with 7. Okay. Or I'll actually do this one. Well, no, I'll do this one right here. Okay, so here we go. Okay, so what I have to do is, what I notice is we got the quantity negative 20 x cubed raised to the 2nd power, and then we have negative x raised to the 7th power, right? So there's 2 different quantities that are raised to different powers, and they're not the same base. So I have to do that product power rule here, and I'm going to do it here, and then I'm going to do it there, okay? So let's go ahead and start here first. So everything inside here is squared. So that means that negative 20 is squared. And also x cubed is squared. So how you do that, you need to do the power rule, which would be x to the 3 times 2. Okay, so that's that first piece. And then we're going to look at this, right? Negative x to the 7th power. So since there is no number in front of that negative, I'm actually going to write that negative as a -1 and call that -1 to the 7th power. And then, so I'm going to kind of look at this as 2 things. And then this is going to be x to the 7th power. Okay? Then I'm going to simplify. So we have negative 20 squared. A negative times a negative is a positive, so our answer is going to be positive for this one. 20 times 20 is just going to be 2 times 2, which is 4 with 2 zeros. so 400. And then we have x to the 3 times 2, which is 6. Then we have this negative 1 raised to the 7th power. And if you think about that, that's going to be, I'll write it up here. Negative 1 times 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 negative 1, right? 1, 2, 3, 4, 5, 6, 7, right? So if you think about it, this negative times a negative, that's going to be positive. This negative times a negative, that's going to be positive. And then a negative times a negative is a positive. And then we're just left with all of these are going to be positive times negative, which means that this is actually going to be ending up being a negative 1. So if you look, there's 1, 2, 3, 4, 5, 6, 7. We started off with 7 negative 1s, and 7's an odd number. And notice how like each of those negatives, they became like a group of 2, group of 2, group of 2, right? And then there's kind of this 1 left over. And that's how you know whether it's going to be negative or if it's going to be positive. It's like if I have negative 1 to the 6th power, right, I'm going to be able to write those in groups of 2. Like that would be this, right? Negative 1 times 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 negative 1. 1, 2, 3, 4, 5, 6. Well, I can make that a group of 2, which is negative times negative is a positive. Negative times negative is a positive. Negative times negative is a positive. So the answer here would end up being a positive 1, right? So basically, anytime you have an even number and negative 1 is raised to an even number, it's going to end up being a positive. But whenever you raise it to an odd number, because every odd number is just a group of like sets of 2 with that extra 1. Like that extra 1 is what makes it odd. And so that's always going to end up being a negative number. So if you had negative 1 to the 7th power, the answer is going to be negative 1. If you had negative 1 to the 9th power, the answer is going to be negative 1. If you had negative 1 to the 11th power, the answer is going to be negative 1. If you had negative 1 to the 10th power, 10 is even, and so it would actually end up being a positive 1. So that's just kind of like a quick tutorial on that. Hopefully that made sense. If not, just ask me about that in class. And then we have x to the 7th here. So now I'm left here, and so what I see is I have numbers. I have 400 and multiplied by negative 1, and then I have x's here, so that are the same base, but they're multiplied by each other. So I'm just going to go 400 times negative 1, which is negative 400. And then these have the same base, so we're going to use that product rule, which when they're multiplied and they have the same base, you can just add the exponents. And then we end up with the answer negative 400 x to the 13th power. And so the thing I forgot to tell you in the last video is on one of the last pages, page 15 of 15, that's where the answers are to check your work. So if you look here, we did number 7. We got the answer negative 400 x to the 13th. This is worksheet 2. So if you go to worksheet 2, number 7, worksheet 2, number 7 is negative 400 x to the 13th. So we got that right. Woohoo! So that one is correct. Okay? So just make sure that you check your answers on this page 15 of 15. So please do not just write them down. You need to show all your work, okay? How I'm solving the problem is how I expect these problems to be solved on your worksheet. So I could make it the long, extended, expanded version, but we're going with the cheat rules. So if we're going to do that, I need you to show your work there. Okay, perfect. Let's go on to number 11. We have a nice little lovely fraction here. So let's go ahead and do it. So here we have 1/2 y to the 5th all raised to the 3rd power and 2y squared all raised to the 4th power. So we have to raise each one of these things to the 3rd power. So that means that whenever there's a fraction, no sweat, you just go 1 to the 3rd power and 2 to the 3rd power. And then y to the 5th, since it already has an exponent, we have to do that power rule, and it becomes y to the 5 times 3. And then lastly, what do we have over here? Well, everything in here has to get raised to the 4th power. So we have 2 to the 4th power. And then y, there's an exponent, so it's power rule, 2 times 4. Okay, then we just simplify this. So 1 cubed is going to be 1 times 1 times 1, which is just 1, over 2 cubed, 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. And then we have y to the 5 times 3, which is y to the 15th. 2 to the 4th, that's going to be 2 times 2, which is 4, times 2 is 8, times 2 is 16. So this is times 16, and then y to the 2 times 4, which is 8. And then I'm going to move it over here. And so what do I see? I see that I have numbers, and I see that I have exponents. So I'm going to write those numbers, 1/8 times 16, right? And then what do I have? I'm going to write those numbers right next to each other, and then I have y's that have the same base, so it's going to be y to the 15 plus 8. Right? Okay, so let's simplify this. So I'm going to make that a fraction, and then we're just going to multiply fractions. So whenever you multiply fractions, you first look to cross cancel, right? So is there a common factor between 8 and 16? The answer is yes, it's 8. 8 goes into 8 one time, 8 goes into 16 two times. You multiply across, 1 times 2 is just 2. And then over 1 times 1, which is just 1. So we have that. And then 15 plus 8 is 23. Right? So there is our answer. We can check it with number 11, worksheet 2, number 11, 2 times y to the 23rd power. Boom, got the same thing. Awesome, awesome. So that is it. Maybe we'll do one more. How about we'll do 13? Okay. So every single thing in here gets raised to the 3rd power. So that's going to start with -3 raised to the 3rd power, x to the, right, there's an exponent, so we're going to go 2 times 3. Y gets raised to the 3rd power. Then we're going to go over here, and everything inside here is raised to the 2nd power. So that's going to be 11 squared, and then x to the 3 times 2, and y to the 5 times 2. Okay, and then we're just going to have to simplify. There's a lot of simplifying going on. So first I'm just going to simplify -3 times -3 times -3. So -3 times -3. A negative times a negative is a positive times another negative. So we know that our answer is going to be negative, right? 3 times 3 is 9 times 3, which is going to be 9 times 3, which is 27. So we end up with -27, and then I'm going to move the number over there closer. 11 squared is the same thing as 121. Okay, so we'll figure that piece out later. Let's do the simplification here with the x's. So we have x to the 2 times 3, which is 6. We have y to the 3rd power. We have x to the 3 times 2, which is 6. And we have y to the 5 times 2, which is 10. Okay, perfect. Then we just need to figure out, simplify this, right? So I have my numbers, I have my variables that have the same base of x, and my variables that have the same base as y. So I just need to figure out what this is first. So I'm going to go 121 times 27. 7 times 1 is 7. 7 times 2 is 14. Carry the 1. 7 times 1 is 7 plus 1 is 8. Now I move to the tens place, so I have to put a 0 in the ones place. 2 times 1 is 2. 2 times 2 is 4. 2 times 1 is 2. And then 7 plus 0 is 7. 4 plus 2 is 6. 8 plus 4 is 12, right? The 2 carry the 1. 1 plus 2 is 3. Okay, and then we have a negative times a positive, which is going to be a negative 3,267. And we have the same base, so we have x to the 6 plus 6, right? Same base multiplied, the product rule, which means you add the exponents. And then y to the 3, they're multiplied, right? So we do the product rule, we add the exponents. And that means we end up with negative 3,267. X to the 6 plus 6 is 12th power. Y to the 3 plus 10, which is 13th power. And if you check or worksheet 2, number 13, yes, negative 3,267. You always have to be very careful about the details because there's so many details. X to the 12th, x to the 12th, y to the 13th, y to the 13th. So this is perfect. Oh, this one was perfect too. So yes, that is it. So go ahead and complete worksheet 2. If you have questions, make sure you come to our math support times. And all right, that's it for this one. Let's go ahead and I'll see you in a little bit for the next example.